Okay. So what I want to do is I want to run through a bunch of these questions regarding forces. Some of them are going to be about like Newton's first law. Some are going to be about the second law, third law, friction. We have all different types of questions here, and I want to run through each one of them. I think I have like 40 questions on here. But let's take a look at the first one. It says, which body is in equilibrium? We have a satellite moving around Earth, a cart rolling down a frictionless incline, an apple falling freely toward the surface of Earth, or a block sliding at a constant velocity. Now, when we're talking about equilibrium, we're talking about all my forces canceling each other out. We're talking about all the forces. Let me show you. So let's say we have a box. Let's say we're applying 50 newtons to the left, and we are applying 50 newtons to the right. Yeah, I have forces on it, right? I have two forces, one going this way, one going this way, but the two forces perfectly cancel each other out. So I wind up getting a total force, which we call F net, right? The total force, the sum of all forces. I wind up getting a total force of 0 newtons. So 0 newtons is my total force. Now Newton's second law tells me that the total force is equal to mass times acceleration. Now, we just said that I have 0 newtons of total force. Well, my mass isn't going to be 0. Right? If I'm applying a force to something, that object can't have 0 mass. It wouldn't make sense. All objects are going to have a mass. But that means I have to have 0 for a value of acceleration. Now remember what acceleration is. Right? If you're driving a car, let's say you're going like 30 miles per hour, and you don't accelerate, that means you don't speed up. If you don't decelerate, that means you don't slow down. That means you have no acceleration. No acceleration means your velocity is not changing. So every single time that you have a constant velocity, a velocity that is not changing, it's not getting bigger, it's not getting smaller, that means you have 0 acceleration. As per Newton's second law, this right here, if you have 0 acceleration, you have 0 net force. So whenever you're in equilibrium, you have to be going at a constant velocity. Right? I'll even write that right here. Equilibrium, just to stress it, equals constant velocity. Because you have no acceleration. So let's look at our options again. Well, it has to be D. Block sliding at a constant velocity across a tabletop. Again, the key word there being constant velocity.